All right, what's up, Capitals? Miss Willis here. I want to pause, rewind, all that good stuff. All right, so first thing we're going to talk about is just interval notation. So if you haven't done so already, I would get out a piece of paper so that you can write these notes. So interval notation. And this is the way we're going to write everything pretty much in pre-calc if it's dealing with an interval, whether that's increasing, decreasing, constant from a graph, domain and range, any of that stuff. You're not going to write it. So a way you could have seen it is, so we'll say old way. X, where X is greater than 7. We're not going to write it like that. So what that looks like on the number line is this symbol right here, the greater than, tells me it's an open circle. So that means it's all the values that are bigger than 7, but not 7. So when we write it in interval notation, we use parentheses and brackets. If it is greater than or less than, we use parentheses as well as infinity. It's only a less than or equal to, greater than or equal to, that we use brackets. So the way we would write this is we would say parentheses 7 all the way up to infinity. Okay, I'm going to do one more. We're going to do X, and it's going to be -3 less than or equal to 8. All right, so that's saying all the values in between those. So since it's X is bigger than -3, it's going to be a parentheses and it's going to go first. And then it stops at 8 and it's going to have a bracket. So like on the number line, if we were doing this, or if it was a graph, at -3, we would have an open circle. It's all the numbers in between and a closed circle. Okay, anything that's open, a hole, whatever on a graph, we're going to use parentheses and infinities. All right, so now we're going to jump right into trig, Sokatoa. Basic trig, that's what we'll call this. Basic trig. All right, so I'm going to do a triangle. So this is what the problem would be. I'm going to write it out. So I'm going to call this problem number 1. It would say solve triangle ABC given that A equals 35 degrees and C equals 15.67. All right, so this would also usually have an angle A there. So I'm going to put that there so you know that's angle. Also has a degree symbol. That is a side, the C. All right, so I'm going to draw a triangle, a right triangle. We're just assuming it's a right triangle right now. All right, so angle A is 35 degrees and side C is 15.67. All right, so right triangles, hopefully you remember, we are supposed to use Sokatoa. So I'm going to write out those. So Soka, so sine. So sine equals your opposite over hypotenuse. Cosine equals your adjacent over hypotenuse. And then the TOA, tangent, is your opposite over adjacent. All right, so what have they given us? Here's our angle. So I like to go through my triangle and label what everything is based on that angle. So let's make it yellow. The opposite side, so this would be opposite. The adjacent means it's the one that's touching it, the one that's closest, it's adjacent to it. And the hypotenuse is always the side across from the right angle. Okay, so we can start with finding the opposite or the adjacent. It honestly doesn't matter. So I'm going to find the opposite first. So I'm going to use sine. Since I know since I know the hypotenuse and I want to find the opposite, I'm going to use sine. So sine of that angle, which is sine 35, equals your opposite, and I'm going to label that as little a, since that's side A. This is side B, and this is side C. Okay, over my hypotenuse, which is 15.67. All right, and then we would solve this guy. So to get a by itself, I would multiply by 15.67 to both sides. And then I just type all of this into my calculator. Make sure you're in degree mode when you're using your calculator for this. Once I type this into the calculator, what I got for side A is 8.99. All right. I have not found everything from this triangle. My suggestion is because you should know how to do this, is see if you can find everything else. I would pause the video and see if you can find everything else. Angle B should be super easy. And then so should side B. Okay. All right. Finding angle B. Remember, angles of a triangle add up to be 180. So I would have done 90 plus 35. And then I would have subtracted that from 180. And so angle B is going to be 55 degrees. All right, there's two ways you could have found side B. You could have, since we have two sides, I could have done Pythagorean theorem, or I could have set up another sign. I'm going to do Pythagorean theorem. You could have done sine. Doesn't matter. We should get the same answer whether you do sine or whether you do Pythagorean theorem. So Pythagorean theorem is a squared plus b squared equals c squared. And I just happen to label that really good. So we know that a is 8.99 squared plus we don't know b squared equals 15.67 squared. So to solve for b, I'm going to subtract 8.99 squared from both sides. And so then I get b squared equals 164.73. In order to finish this problem, we are going to have to square root both sides. And I get that b equals 12.83. All right, I'm just going to quickly talk about something so that you can solve problems in class. I'm going to talk about what the angle of elevation and the angle of depression are. So depression means I'm like looking down. So if I was flying in a helicopter, so I'm going to write this angle of depression. Let's say I was flying out of a helicopter and he had an angle of depression looking down at something, blah, blah, blah. The angle of depression is 34 degrees. That angle would be right here. Okay? Angle of elevation. So say, usually it's like, okay, well there's a guy standing on the ground looking at a helicopter and his angle of elevation is 34 degrees. So that would be formed with the ground. And then you would solve using Sokatoa, whether you're given, whatever you're given. Okay? All right. next thing I'm going to go over is our favorite factoring. I'm going to teach you a couple of different ways to factor. So we'll see how that goes. I'm going to title this as factoring. All right. So let's do this first problem. Start off easy. X squared plus 5x plus 6. All right, so why is this easy? The leading coefficient is 1. So you multiply a times c. 1 times this, and that's 6. I need to find the factors of 6 that give me 5. So 1 and 6, 2 and 3. That's it. All right, so since this is a positive 6, it's going to have to add to give me 5. Because the only way I can get a positive 6 is by either multiplying 2 positives or 2 negatives. And if they have the same signs, you always add. So 1 plus 6 does not equal 5. It's 2 and 3. I know I'm breaking this down. That's why we're flipping the classroom, so that I can break it down. Just in case, you know. And then that's your factors. Probably shouldn't have just jumped into that, because I do it a different way. When there's a leading, that only works if there's a leading coefficient of 1. If there wasn't a leading coefficient of 1, you're either going to have to do grouping, or I do something that I call divide, reduce, and slide. I'm going to show you both. You get to choose how you factor. I don't care how you factor, whether it's backward box, grouping, or divide, reduce, and slide. If you need help with any more of these, I have tutoring on Wednesdays. If you have Miss Fisher or Miss Marshall, then you can go to also their tutoring hours. All right? So, or mine, whether you have Miss Fisher or Miss Marshall, doesn't matter. Here's another problem. 3x squared plus 2x minus 16. All right, so what we're going to do is we are going to multiply. And when I multiply a times c, 3 times negative 16 gives me negative 48. And I like to list out, again, all the factors. I teach Math 1, so my brain is very break it down. 1 times 48, 2 times 24, 3 times 16, 4 times 12, 6 times 8. All right. Oh, you're probably wondering why I got sub. Sorry, I jumped ahead. So remember how I said before, when it's a positive 6, I'm going to have 2 numbers that are adding because they're going to be the same signs. This one are going to be different signs. And when they're different signs, in my brain, I think, okay, 2 numbers that have to subtract to give me 2. Well, 1 and 48 doesn't. This doesn't. This doesn't. This doesn't. 6 and 8 subtract to give me 2. And it's going to be 8 minus 6. That gives me 2. All right, so I'm going to finish my new way. This is what I call divide, reduce, and slide. So I would set it up, since that's a positive 8, it would be x plus 8. And since that's a minus 6, it would be x minus 6. Now, when you're doing it this way, if you're not going to group, you have to divide by this leading coefficient of 3. And I divide both of these by 3. Okay? It's like, since we didn't take out a GCF, we have to put that back in. And I'm going to show you again the grouping. 8 and 3 do not reduce at all. So, again, I call this divide. You have to reduce. And then if it doesn't reduce at all, you have to slide. Now, when I say reduce, if it was 4 over 6, that reduces. So I would reduce it and then slide over the remaining that can't reduce. So this doesn't reduce, so it becomes 3x plus 8. This reduces. 6 divided by 3 reduces to 2 over 1. But I don't have to slide over 1 because it's always in front of x. Okay? Now, if that was, again, like I said, 4 over 6, if it reduced to 2 over 3, then I would slide out the 3 because you wouldn't have fractions. So that's that way. Grouping works the same way. You got this 8 and 6. Okay? 8 minus 6 equals 2. So you would set it up as 3x squared plus 8x, because that's a positive x, minus 6x, because that's a minus 6, minus 16. And then you have to take out the GCF. So the GCF here is x, and then I'm left with 3x plus 8. The GCF here is negative 2. And then I'm left with 3x plus 8. And in grouping, we want these to match, and they do. So one of my parentheses is 3x plus 8, and the other parentheses is what is on the outside, x minus 2. Look at that. Same exact answer, folks. All right. I'm going to do one more problem of factoring, and then we're going to move on. Let's just do x to the 4th minus 16. All right, so we have no middle term. That means it's 0. That means something gave me 0. This is what we call difference of squares. They're both perfect squares. You can set it up the same way. That x to the 4th might throw you off just because it's not a squared. Well, it's not x squared. You're like, oh, it's not a quadratic, but it's still a perfect square. It's still x squared times x squared. So that's how difference. So first squares, x squared times x squared. Squares means I'm multiplying the same, and that's 4 times 4. Difference means I'm subtracting. So if this was a plus sign, then I wouldn't be able to factor. But it is a minus sign, therefore it is a difference of 2 squares. So difference of 2 squares is just setting up your 2 parentheses. X squared plus 4 and x squared minus 4. Now look at these parentheses. They're all perfect squares again. This is a plus sign though, so I can't factor it. This is a minus, so I have another difference of squares because x times x and 2 times 2, and they're being subtracted, difference of squares. So I have to further factor this, x minus 2 and x plus 2. And then I have x squared plus 4. How do we feel? Hopefully you feel good. I don't know why I asked you a question. It's not like you can respond to me, but it's cool. It's cool, it's cool, it's cool. All right, we're only going to do, like, I don't know how many more problems. Almost done, though. All right, done with factoring. We're going to go over synthetic division real fast. I'm going to do one problem of synthetic division. And you might be like, well, this is not enough. Like, I don't get what you're doing. Guys, remember, this is just me teaching it, and then you're going to have to practice it in class. I am not reteaching it in class. Miss Marshall's not reteaching in class. Miss Fisher's not reteaching in class. We are helping you with all the problems, okay? So, synthetic. Let's do a good one. Factor using synthetic division. All right, so we're going to have to use our calculators. So if you don't have your calculators, get them out. I'm just going to do x cubed minus 64. So I'm going to go to my calculator, and I'm going to type it into y equals. So I'm typing it in. Once I get it into y equals, I want to hit graph. What we are looking for is where that graph crosses the x-axis. And if you look at it, you can see that it crosses nicely at 4. So that right there tells me I'm going to synthetically take out x equals 4. It's straight through 0. You want to double check that it's a 0. The way you can double check that it's a 0 is you can go to your table, and so that's second graph, and then go to 4, and it should be a 0 at y. Okay, if it's not, then this is not a synthetic number. Okay, so it goes in the box here. Now what we need to do is put all of our coefficients. Well, you notice that there's not an x squared and there's not a linear term, an x. So I'm going to have to put placeholders. X cubed is 1. Since there's not an x squared, I'm going to put 0. Since there's not an x, I'm going to put 0. And then I have negative 64. It has to go in order, so I'm going to write this and then erase it. This is the leading coefficient of x cubed. This is the leading coefficient of x squared. This is x, and this is my constant. If there wasn't a constant, I would put a 0. Okay, so you have to go in order of the powers, the exponents. All right, first step you do is you drop down the first number, and then I multiply that by the number in the box. So 1 times 4, that is 4. Next part of synthetic is you just add. 0 plus 4 is 4. So I added these two numbers right here. And then I repeat the process. I multiply this 4 times this 4. And that gives me 16. Now I add. 0 plus 16 is 16. Then I multiply again. So 16 times the 4 in the box. You're always multiplying them by the number in the box. 16 times 4 is 64. And I get 0. That's my remainder. That right there tells me this is a factor because it's 0. We'll talk about when it's not later in the school year. All right, so the way to write this as a factor is x minus 4. That comes from right here. That equals 4, but to make it a factor, you have to move it back over. It's always opposite. Now, I'm going to use the numbers down here. 1, 4, and 16. That are the leading coefficients of my new equation from when I divided that out. So when I divided out that x, it's going to make that x cubed and x squared. 1x squared, because we took out an x with that x minus 4. Then I have 4x, I just go in order, plus 16. Okay, cool. All right, that's the only synthetic I'm doing. Now I'm going to do, we're not going to solve by factoring. You guys can do that. Once you factor, if it has a equals 0, you just set your factors equal to 0 and solve. All right, we're going to solve by the quadratic formula. Actually, before I do that, solve by factoring. We'll just do the one we already factored. Because you need to know what it looks like. It has an equal sign. Sometimes it's not equal to 0. So it might look like 3x squared plus 2x equals 16. You got to set it equal to 0 first. I'm choosing the problem that we did with factoring so that I can just write down the answers. Once I do this, I factor it, whether you do divide, reduce, and slide, or you do grouping, okay? So I would get, once I factor this, I would get 3x plus 8 and x minus 2. What you're doing is setting them equal to 0 and solving. So I get 3x equals negative 8, x equals negative 8 over 3 when I solve that. And here I get x equals 2. Those are my factors. Solving by quadratic formula. All right, so I give x squared plus 2x equals 1. Still has to equal 0, just like with solving by factoring. X squared plus 2x minus 1 equals 0. All right, quadratic formula. You should have learned this. Somebody might have taught you a song. goes like opposite of b, plus or minus square root, plus or minus square root, b squared minus 4ac, b squared minus 4ac, all over 2a, all over 2a. Hopefully it's stuck in your head now. All right, so again, what was that? Opposite of b, you want me to sing it again? JK, I'm not doing that again. B squared minus 4ac, all over 2a. All right, there's a 1, that's a, this is b, this is c. Plug and chug, dudes, plug and chug. Opposite of b, plus or minus square root of b squared minus 4 times a times c, all over 2a. Whoops, I'm sorry that rotated. I apologize. So once you clean that up, you get negative 2 plus or minus square root of 8 all over 2. You think you're done. You're not. You need to reduce this guy, jailbreak it, whatever your former teacher called it. You're trying to find a perfect square that goes into 8. What perfect square goes into 8, y'all? 4. So it's like writing it as the square root of 4 times 2. Well, the square root of 4, the square root of 4 times the square root of 2. The square root of 4 equals 2 root 2. That's what you're doing. So negative 2 plus or minus 2 root 2. Now notice everything is divisible by 2. I don't care about the radical. We can't go inside the radical. Illegal move, flag on the play, not allowed to do. Also, you were not, and I'm just going to try to stress this, these 2's right here in the very beginning cannot just cancel. It has to go into everything, y'all. Everything. Every 2. So really what this is it's negative 2 divided by 2. I'm breaking it up. Over 2 over 2. I broke up the fraction because I am reducing it to negative 1 plus or minus root 2. Did I have to show that? No. You could have just said everything turns into a 1, which is exactly what happened. All right, last problem. Completing the square. Ooh, I can't spell. Wait, I was spelling that right. Never mind. Completing the square. All right, here we go, dudes. X squared plus 8x minus 2 equals 0. Now, you probably have learned this different ways. I try my best to be consistent, but here we go. So what we need to do is, what I like to do first is isolate the quadratic term and the linear term. So I'm going to move over the 2. X squared plus 8x. When I move over that 2, it becomes a positive. Now I left this space intentionally. Okay? Whatever I got to put something here to make this factorable. The whole goal is we're trying to make this x squared and 8x factorable. So you take whatever b is, you take half of it, and then you square it. So half of b, 8 divided by 2 is 4. 4 squared equals 16. That is what goes in your blank. Plus 16 plus 16. It's always going to be a positive because you're squaring it. All right? ESPN update, in case you were wondering. Now, I need to factor. When you factor, it just becomes half of whatever b is. So this is b, 8. This becomes positive 4. If it was a negative, it would have been a negative 4. Equals 18. Okay, to finish solving, all you got to do is square root both sides. X plus 4 equals plus or minus root 18. Why plus or minus? Because when you square something, it's plus or minus. Finish solving. Almost done. X equals negative 4 plus or minus 18. But guess what? That can be simplified. We got to jailbreak this. What perfect square? So when I say perfect squares, the first perfect square is 4. 3 squared equals 9. 4, so on and so forth. These are my perfect squares. 9 goes into 18. There's not anything bigger because 4 squared equals 16. That doesn't go into 18. And then 5 squared is too big. So the perfect square is 9 times 2, which is the same thing as root 9 times root 2, which guess what root 9 is? 3. Negative 4 plus or minus 3 root 2. If you don't simplify, you will lose points, period. All right, guys, it's been real. I tried to make this short, but I don't think I succeeded. It was a lot, y'all. Sorry about it. Later.